Welcome one, welcome all. Welcome to another installment of LeetCode, where we are going to be solving questions. So this is the second day, not the second day, but the second time today that I'm doing a YouTube live stream. So just a quick introduction about myself. I started doing Reddit live streams a while ago. Well, by a while ago, I mean about a week ago. And then as soon as I saw that YouTube Live was an option, I decided to start coming on the LeetCode platform more often. Not the LeetCode platform, the YouTube platform more often, because I figured since I was already on their ecosystem, in their platform, then this might be the best way for me to continue. I also feel like it helps for people that are watching on mobile because the screen will be fitted nicely. On Reddit livestream, it was hard to grab people that were on mobile because there wasn't an easy way for me to stream to them specifically. So I'm hoping that with YouTube, it's easier. So today we're going to be solving some more questions. I started a week ago on question 1, and now we've done 62 questions. So we're going to hit that 100 question milestone soon. I'm very excited for that. And without further ado, let's get it going. I hope that we can solve some questions today and have some fun doing it. So let's see. Let me sort this how I normally do. By acceptance. And go from here. All right. So here we go. Sum of all. I notice now there's some of these that we haven't visited yet because I thought they were probably too tricky for a stream. But we will get to them eventually. Normally at the end of every week, I like doing like a sort of weekly roundup. And depending on the questions that I have, we'll decide to solve those at a later point during the week. Okay, so the XOR total of an array is defined as the bitwise XOR of all its elements, or 0 if the array is empty. For example, the XOR total of the array 256 is 2 XOR 5 XOR 6. Given an array nums, return the sum of all XOR totals for every subset of nums. An array A is a subset of an array B if A can be obtained from B by deleting some or possibly however many elements. Okay. So 4 subsets of 1, 3 are empty subset, which is 0, and 1 and 3, and then 1 or 3. Okay. And then 5, 1, 6. Empty subset has an XOR total of 0. 5 has an XOR total of 5, 1, 6, and then 5, 1, 5, 6, 1, 6, 5, 1, 6. I mean, this is something that we can, this sounds very familiar to, we can do this recursively. This sounds a lot like the normal subset problem. I mean, we could 5, 1, 5, 6, then 1, 6. We can brute force this, but we can also generate all the different subsets and then go from there. It seems interesting for an easy problem. But if we do 5, 1, 6, then 5, 1, 5, 6, 1, 6, 5, 1, 6, 28, the sum of all XOR totals for every subset is 380. So I suppose that we should go about trying to generate every single subset. I guess that's the way that we can start. So let's see what we can do. And let me see if I can draw this out. I'm going to open a window in Excalidraw. And you can see I have some stuff here left from previous times. But let's do 2, 5, 6. So let me get my text tool here. Let's make this extra large, 2, 5, and 6. Now what is that we want to do here? Like if we're given an array like this, how can I generate all the subsets? So let's imagine that I started at, like this is one subset, right? Or maybe the subset should be generated from, maybe we have 2, 5, 6, but the subset is generated just from an empty array, right? Let's say something like this. I'm gonna have this 2, 5, 6 up here. Now imagine I have a pointer, like I have some I variable up here. So what happens here? Like now I'm at I 2, 5, 6. So what happens if I branch down in here and then I create a new array. Let's say I have 2. Now, if I look in here, I have 2, 5, 6. Can I pick? Do I want to pick the next thing? Or maybe, like I have 2 that I send that way. Okay. Now when I'm in this next piece, can we get 2, 5? Or do I just start at 2 again? No, I wouldn't start at 2 again because that's 2, right? So is an empty array a good place to start? Or maybe the best place to start? Let's go again with this piece and see what we can do from here. If I'm at I equals 2, 5, 6. Yeah, I guess we can do an arrow. That's fine. Where I equals 2, 5, 6. And right here in the beginning, what if we had sort of like a 2 and a 5, 6? Okay, and then now we have the 5 that we can pick from. So maybe here we do 2, 5, and 6, right? And then now we have the 6 to pick from. So maybe from here we can do another 2. Well, we can do 2, 5, 6. 2, 5, 6, and then we have an empty array, right? So I can't do anything with I up here. If I go up here, now whatever pointer I had at 6 is out of bounds, so I can also return from here. But now this one becomes 6, so maybe in here we can sort of do 2, 2, 6, and we can just essentially ignore 5. And then we come up here, and now the I increments. So we have over here we can have 5 and 6. Oh, that's the wrong tool. Over here we can have 5 and 6. And what do we know when we have, like when we have 2 to choose from, we have 5. Well, let's see, I removed the 2. No, I think here we just have 5, right? I removed the 2 and I was left with 5, 6. Here I should remove the 5 and I'm left with 6. Something like this. And then from here I can do 5, 6, and I'm left with empty, right? And then I return from here, this is out of bounds, and then finally I go to the 6, which this is going to be a crazy looking tree, but I have a 6 and I'm left with empty, so that's it. So let's count all of them and see all the different ones we have. Do we have each individual number? I would expect to see a 2. Like we have a 2 here, we have a 5 here, and we have a 6 here, so that's good. We have a 2, a 5, and a 6. And maybe I should do a 2, a 5, and a 6. Do I have a 2, 5? I do have a 2, 5. Do I have a 2, 6? I do have a 2, 6. 2, 6. Okay. Do we have a 5, 6? We do have a 5, 6. 5, 6. And do we have a 2, 5, 6? Yeah, we have a 2, 5, 6. So that's going to give us all the different, I know I created like multiple text elements here, but this will give us all the different subsets. And then in here, we can create a function that will calculate the XOR of all these different ones. So something like that. That's what I'm thinking. Now let's see if we can put this to code. Right, before I actually start writing anything out, before I go on LeetCode, right? Like every single time what we did in here, what's our base case? The base case looks like any time, like if this is empty, if this for sure is empty, we just break. So if nums.length equals 0, then maybe in here we can add the current subset, like to our, we can add, let's say something like current subset, or subsets.add subset, subsets.push. Let's do subset like this. Subsets.push subset, and then from here we really could just return. We could return else. What is it that we want to do? We have our index here, so for let I equals 0, I less than what nums is, nums.length, I plus plus. We're going to generate a new subset. is going to be equal to whatever is at the current I. So here we can say something like nums, or we can say new subset equals, let's say the current subset dot concat whatever is at nums of I, and then const new nums. What will this equal? Like I want to slice, or I don't want to slice, I just want to remove. I really just want to get like from I plus 1 forward. Can we do that? So like what happens here, right? When I'm at this, let's say I get this new thing, now my I is at nums, I dot length. I get this, and then I plus 1. Can we slice starting at I plus 1? We can say new nums equals nums dot slice I plus 1. And then maybe here we can call our subset with new subset, new nums, something like this. This is sort of like what I'm thinking here. Just a way of me like planning it out. So let me go back. It seems a little bit, it honestly seems pretty complicated for an easy question. And there might be a better way of doing it, but let's, yeah. Or 0 if the array is empty. So let's see. Oh, subsets with the same elements should be counted multiple times. Oh, that's fine, because I'm not even doing anything to make sure that it won't be. Okay, so in here, let's create a new function. I want to do some stuff in here. This is going to return a number. I just want to clean this up a little bit. Let's come over here. Let's do this, but now I'm going to create something new in here. We can say const XOR total of, let's say, list, nums list. And here, maybe we can just return, I think we can just return nums list dot reduce ack val. Let's do this. Start off with 0. Should it be 0 though? Shouldn't be 0, right? It should be, I think if I leave this off like this, I'll just take the first value, and here we can just return. Yeah, so let me actually remove this. Here what I want to do is make it, sorry, I'm getting some notifications on my phone. Let me just mute this because I know the mic is probably picking it up. Let's return here ack XOR val. Now if it's empty, what will it return? XOR total nums list. So I guess, you know what, let's do some more logic in here. Here we can say if nums list dot length equals to 0, return 0, or return nums list dot reduce of accumulator and the value. We'll do ack val. So we can do this. This will give us the XOR total of any given subset. And then in here, let's create a new array called subsets, which will take nums. Let's say subsets is an empty array. The current subset is an empty array. And then inside of here, we'll call subsets with, let's see, we can call subsets with nums. That will go and start this whole recursive function here. And we want to return the sum of all the XOR subtotals. So anytime, let's see, we can create our sum out here, and then we return sum. Right? So out here is going to be where the bulk of our algorithm happens. So anytime we, let's see, based on that picture, the subset will just be any one of these new frames, right? We just have the base case here. We don't really need to wait. I mean, we just need to make sure we don't keep going. But anytime, yeah, as soon as we get to empty, so we can say that if nums.length is equal to 0, here we can return. But if I call this with nums, and I start doing, yeah, I should pass in, yeah, here we can say subsets subsets.push nums. I think we can push it immediately, right? That'll give us that one. And then here we can do for let I equals 0, I less than nums.length, I plus plus. We can say const new nums will be equal to the current nums.slice of I plus 1 and new subset. Subset.push nums. New subset will be equal to, let's see, the current subset dot concat whatever is at nums of I. And then here we can call subsets. Here we can maybe say like generate subsets nums or new nums subsets new subset. Do we even need this though? I think with nums it's okay. I don't think I need subset. Maybe I can just do this. New nums. So I call it with 256. I pass in this. If nums.length equals 0, return. Do I still want to pass in subsets with the same values? Like how many times do I generate that first one? Yeah, so maybe I'll do this. That way I don't ever... Well, if I get to 26 here, this will be empty, but I do need to include it. Let me think about this. Okay, so maybe I do need that subset. Nums shouldn't be the subset. Yeah, so let's do this. Let's still create our subset over here. So if subset equals, so subset starts at this, but the next time I call it, I get to that. So I can always, yeah, I think we can do this. Subsets.push subset. This will start off as an empty array. And then and we can start building this as we go along. So new nums, subsets, and new subset. Subsets.push subset. Here we can say sum plus or equals XOR total of subset. Also just realize that I don't need to really keep track of the subsets, right? But let's see if this works. XOR total of subset. It seems like we're doing this multiple times. That's one thing I would like to improve on, but let's give it a shot. Okay, subsets. Oh, I think here subsets generate subsets. Yeah, I don't need to keep track of my subsets here. Just to reduce the complexity of this. Let's do that. 6 and 6. 6 and 28, 480, 6, 28, 480. 9.8. So based on the performance of this question, I am so sure that there's a faster way of doing this, and maybe I completely missed it, but when I look at a question like this, it just reminds me so much of the subset problem. So is there a cost of me sum plus or equals, maybe here I can just do if, let's see, of subset, if subset.length greater than 0, then here I can just do this and then forget about doing the checkup here, and then we can just condense this a little bit, make it a little bit nicer, and really just like, honestly, I can just inline this XOR total of subset, so we can just do this instead of nums list. Let's just do AV, return AV, make it very condensed. We can get rid of this function call up here, so it's a little bit more condensed now. And I think finally, even if this is recursive, let's see. Yeah, I mean, I'm happy with this question because I feel like I'm happy with my answer rather, because I feel like at least I still know how to generate these subsets. So I have that skill still because I know that's a medium question, but I'm extremely interested to see what people are doing here. One-liner with a bit mask. Backtracking approach with explanation. Is this not all subsets? Yeah, we can, exactly. This is feasible solution, not unnecessarily smart. One-liner plus a bit mask. I'll start with the one-liner, but we may have to check out approach 2 first. Okay. This is very clever. Some of these I don't even like to mess with, and there's no solution here. I would like to see short solution, simple approach with explanation. Add that to the result. Here the trick is to use binary representation of numbers to generate the power set. I mean, how do you... This, I think, honestly, like if you were able to... I think that if you were able to generate all the subsets in an interview, that would be fine. I mean, it is a medium question, so it's like a skill they expect for you to have. Again, for the sake of the stream, I'll just leave that as is. But let's keep on going here. So, number of rectangles that can form the largest square. You're given an array of rectangles where rectangles I represents the ith rectangle of length. Okay, you can cut the ith rectangle to form a square with a side length of k. If you have a rectangle 4, 6, you can cut it to get a square with a side length of at most 4. Let max length be the side length of the largest square you can obtain from any of the given rectangles. Return the number of rectangles that can make a square with a side length of max length. Can I see an explanation? Okay, so rectangles 5, 8, 3, 9, 5, 12, out of 3. The largest squares you can get from each rectangle are of length 5, 3, 5, 5. You're given an array of rectangles where rectangles I, length and width, represents the ith rectangle of length L and width. Okay, so length and width. You can cut the ith rectangle to form a square with the side length of k if both k is less than, for example, if you have a rectangle 4 of 6, you can cut it to get a square with the side length of at most 4. Oh, so it's always the lesser of the two. Like 5, 3, 5, 5 is of length 5, and you can get it out of 3 rectangles. Okay. So I think here we're just getting the max of all the minimums, if that makes any sense. If we get the min of 1, we store that, but we also need to store, let's see, we can keep track of the max and also keep track of the frequency. I think here we can keep track of max and keep track of frequency, right? Because let's say our max here is 0, and we have a frequency. So let's go through each one of these. For const rectangle of rectangles, just to make sure I'm spelling that correct. Here we can do const length width. We'll use array destructuring to be able to like nicely name these. And now we get the min. So const min side, I guess, is the math.min. Math.min of length and width. We get the smaller of the two. And now we say max equals math.max of max or the min side. And then in our frequency, we can say frequency of max equals frequency of max plus 1 or 1. And then at the end, we just get, I think at the end here, we can just return frequency of max. I think we can just do this. 4 and 3. So 5. Oh, but wait a second. The min. The max and the min side. We don't always. Yeah, we always need to. We need to increase. Yeah, we need to always. We need to add the min side here. But the max is always. Yeah. There you go. I think that will be right. We have, let's see, 3, 3, 3, 3. When both are the same. Okay, 36.57. Okay, so what we did here was we took, what you do is you take the minimum of each one of these, right? So you have 5 and 8, and now you can store this inside of a frequency array. You can store them inside of a frequency array, so you know like how many times the minimum one here appears, right? But then the max is going to be either the max or the min side. So out of all these, for example, like 3 is the minimum and it appears once, but 5 is also the minimum of all these other ones and it appears 3 times. So it's a combination of keeping track of the max and also keeping track of the frequency by using one of these right here. So I wonder if like, okay, cool. So I'm happy with this. Let's submit it again, see what we get. 21.71. 41.71. Let's see what the discussions have to say. 1 pass on time 01 space solution with sorting. So we did it in on time, so that's fine. Now 01 space. Do we need to have, what can we do? Largest squares, mean constant space, rectangles, length. Oh wait, but what do we need? What's the size of the numbers? Oh, it's 10 to the 9. That's massive. But maybe we don't need this, right? Frequency, number of rectangles. Let's see what this person did. 3 cases after initializing the counter. And the max side, the greater than mx, reset counter to 1 and update mx. Plus count. 2 pass solution. Should be on time and 01 space complexity if local max greater than max lane, count max equals 1, max length equals local max. Okay, the local max, if that's greater than max length, then count max equals 1. If it equals, oh, so they're not storing it per se, they're just saying if the local max is equal to the max length. So max length is local max. I see. Yeah, this is a nice optimization here. Definitely something to consider when going through these questions. All right, let's keep it going here. I think I lost track of where we were, so just give me a second. All right, so let me sort again by acceptance. Let's go all the way down here. Find the first palindromic string in the array. The first string that is palindromic is Ada. Note that race car is also palindromic, but it is not the first. I wonder, I feel like we can do something very Java, like there's Pythonic, we can do something very, let's see, the first element that satisfies the provided testing function. Our testing function could just be const is palindrome, where this will take a word, and we'll say for let I equals to 0, j equals to word dot length minus 1, I less than j, I plus plus j minus minus. If word at I not equal to word at j, return false, else return true. So we can return words dot find index, and this returns, let's see, -1 is returned. Words dot find index of word, or we can just say is palindrome. So if this equals -1, return an empty string. Oh, and is that not gonna words dot find index? Oh, but we can't capture the variable. But we could do, okay. Const found palindrome. Const palindrome equals words dot find index of is palindrome. This is going to return an index, so if palindrome equals -1, we can return an empty string, or we return words at palindrome. Will it be this? Eta. Here we have race car, empty string, empty string. I mean, is there no, like, I feel like this is reasonable, right? We need to absolutely check whether a string is a palindrome. Like, every string needs to be a palindrome. So this will be n by n and constant space complexity. N by n time complexity because we're going through all the words and then iterating through every character of every word. Assuming those are all different, it'll be n by n, and space complexity because we're not creating any new array. So I want to do something really quick. I want to share this with some people. Let me see something. I'm going to open up I am on my Discord currently, and I want to go through, let's see, I'm going to post that I'm going through some stuff here. So if I put easy here, streaming on YouTube right now, or I can say currently streaming on YouTube and going through some easy questions. Join in on the fun. Okay, cool. So daily dose of LeetCode stream. So for anyone watching, I see there's no one currently watching right now, but it's good practice for me just to talk about it. If anyone's watching, I'm really happy to have you all here. This is good for me to practice, and it's also hopefully good for people that are watching. Hopefully you all can gain something from this, learn something just by seeing me go through every one of these questions here. I've been doing this a little bit over a week, and I've been having a lot of fun with it. I know some people have told me that they have benefited from it, so I think that's very neat. I'm very excited to see that. I think that's definitely one of the reasons that I started this, because I have been in that sort of pit of despair where it's very difficult for me to get out of. I have like massive imposter syndrome, and I'm just like, oh, I can't do it. LeetCode is really hard. I'm never gonna get there. But like the more I keep doing it, the more I keep doing this thing, I realize there is a way. Like there is light at the end of the tunnel. So it's very cool just to like see that with consistency, you really can't do anything. So again, like if anyone's watching, really happy. I should probably talk about the YouTube channel again. So I've been making like a lot of changes. I've been trying to do research to make this like the best that I can. And for anyone that's here watching, like there's a playlist on the channel where you can start from this first one here, and I even named it as such, like LeetCode accountability stream, number 1, start here. And I started off with accountability stream, and then you can see that like the names have changed, and finally like we are where we are today. So the idea with all this, and you can watch the channel introduction where it tells you all this already, but the intent is like to have a study buddy to go through all this stuff with. You can watch you can watch the videos and do the questions. Like every single playlist here, every single question has, like if we look in here, every single one of these videos on the playlist has chapters to all the questions and all the links. So you can watch the video and do the questions at the same time, or do the questions then watch the video, and hopefully it'll give you like, it's like a study buddy. It's a fun way to keep track of it. You just have a playlist you have to follow, and everything else is good. So anyway, let's keep going on through here. We just finished doing find first palindromic string in the array. So just solved this one. I'm pretty happy with this one. Let's move on from here. Let's see. So let's go back to problems. So find the highest altitude is this next one right here. Okay, so there's a biker going on a road trip. The road trip consists of n+1 points at different altitudes. Excuse me. The biker starts his trip on point 0 with altitude equal to 0. You're given an integer array gain of length n, where gain I of length n, where gain I is the net gain and altitude between points I and I+1. Return the highest altitude of a point. So is it just trying to see, let's see here. Is this saying biker's going on a road trip, road consists of n+1 points. Biker starts his trip on point 0 with the altitude equal to 0. Okay. Or n gain is the net gain and altitude between points I and I+1. So this is how much he gained. So let's see if we can draw this out. Oh, so he went from 0 to -4, or 0 down to -5. And then what? He went up to 1, and somehow that's -4? The altitudes are 0. This is just like a weird question to read here. Length n, where gain I is the net gain and altitude between points I and I+1. So gain I is the net gain of altitude between I and I+1. So the altitudes are 0 to -5. Okay, here it's 5. Oh, okay, 5 to -4. Okay, I see what we're doing here. I think I do, but let's like draw this out here. So we have this array. We have some array here. Let me make this larger. All right, so 5, 0, and I guess we start at 0. So like we start at 0, and that's not even, okay, we start at 0 right here. And then we go down to -5, which I'll represent by some random point over here. I don't know, maybe this is like -5. Okay. And then the gain from, like, to get from I to I+1, a gain of 1. All right, so now we add 1 to -5. That gives us, let's say, -4. And then we add, I want to keep track of this as I'm going along with it. So that's -4. And then we add 5 to -4. That's going to give us 1. So it should be just over where we started, like right up there. That's going to give us 1. So that's 5 to -4. We got 1. And then 0. So we just stayed flat here. And I'm using all sorts of different controls here, right? Okay, 1. We ended up here. I think I can just copy this guy. And then we went to -7, so that's going to be what, -6? -6, right? Okay, so I think what we want to do, so we say we start at 0, we subtract, or can we just always do, no, I think we can do 0. Yeah, what if we say let current, I don't know, maybe let current height equals 0. And then let's say max height equals Should it be 0 though? No, I think I'm gonna make this negative infinity, like some crazy low number. Let's go through each one for const g of gain. Okay, so from 0 to -5, it's this. So the current height is going to be, or maybe the max height. Should the max height be 0? Like I'm never gonna go higher than that, right? Altitude equals to 0. So let's do max height is equal to 0. Let's first calculate 0 to -5. All right, so the current height will be, altitude is 0, and then to get to -5, we can say current height minus equals g, or let's do plus or equals g, and then max height, or can we just keep doing max height equals math.max of max height or current height plus g. So max height here, if we just go from the beginning here, max height is going to equal 0 or current height 0 plus -5. So we're going to pick, let's say, m equals 0 for those. But then we want to make current height equals or plus or equals g. So m is 0, current height equals -5. Now we come to the next one. Max of height equals 0 or current height -5 plus g, which is 1. So 0 or -4, it's still 0. Current height now equals -4. Then we get to the next one, which is 5. Max height equals math.max of 0 or current height plus g. So that's 1. 1 wins, and then this becomes 1. So I think if we keep doing this all the way, we can just return max height. See what this does. 1 and 1. Of course, I waited too long. 1 and 0, 1 and 0. Okay, 78.49. Yeah, pretty happy with this. I wish there was like a timer for every single time I opened one of these so I knew exactly how long I took on it. But I think the drawing here definitely helped, so that's always good to do. So yeah, I mean, this is a linear time solution with a constant space complexity. So I'm pretty happy with this. All right, so let's keep moving here. Cells with odd values in a matrix. Okay, so there's an n by n matrix that is initialized to all zeros, and there's also a 2D array of indices where each indices I represents a 0 index location to perform some increment operations on the matrix. For each location indices I do both of the following: increment all the cells on row Ri and increment all the cells on column Ci after applying the increment to all locations. Okay, so we have m by 2, n by 3 initialized to all zeros, and the indices are 0, 1, and 1, 1. For each location indices at I, okay, increment all the cells on row 0. So on row 0, increment all of them by 1, and then increment all, oh, interesting, okay. And then 1, 1. So I mean, is this just like a brute force sort of thing? Which contains 6 odd numbers. Do we really have to go have an m by m matrix for indices? Get the first one on row 0, do all of those that way, and then for the columns, the column becomes a little bit trickier. right? Because for the row, we can just start there, and for the column, it'll just have to be, yeah, it'll just have to be the same thing. Let me see this one. Yeah, I mean, the like to dislike ratio says enough already, but there's an m by m matrix that is initialized to all zeros, and then we just have indices. So on top of that, I also need to create, my own array. So const matrix equals new array with m, new array at m dot fill. Let's see. Can we do? Yeah, what would be the best way for me to do this? Like new array at m. For each one, can we just return a map of each array and return new array at n dot fill 0? I just need to see what this actually logs. Console.log matrix. Can we just see what this returns? This is actually like a good way of, okay, 2 empty items, so I don't even have, I know there's like a nicer way of creating 2D arrays. I should look that up again because I always forget, like creating 2D arrays in JavaScript, but like using, there's like one nice one that you can use, like spread operators. Var items, nope, not that one, not this one. Right, I'll create an empty two-dimensional array, one line. Not that one. Okay, well, yeah, we can create it like literally. Two-dimensional array. Two-dimensional array in JavaScript. Creating and accessing two-dimensional arrays in JavaScript. Creating 2D arrays in JavaScript of specific size. Length and width close. Array constructors. New array, update, some crazy thing. Two-dimensional array. Is it really just this? Yeah, I'll just do this. I'll just copy this one for now. There was like I could have sworn there was a nicer way of doing it, but let x, say let matrix equals new array of m, and then for var I, x of I, new array 3. Yeah, that's pretty much what I did before, right? But I have 2 empty slots. Those are not actually filled with anything. I'm like struggling more with creating the array. And what is this supposed to do? Console.log x. Undefined, undefined, undefined. Okay, so let's just do it with matrix. Let I equals 0, j less than, let's see, n. Matrix of I, no, I less than m. Matrix of I equals new array n dot fill 0. Console.log matrix. Just to see. Okay, 0, 0, 0, 0, 0, 0. Okay, great. So we have our matrix. That's out of the way. Cool. So now let's figure out how we can loop through each one of these. So we're gonna go through indices. So for const, I guess, index of indices, we're getting a const row and column equals index. Okay. Const row equals index. This will give me the row and column of the index using some array destructuring, so it comes out a little bit nicer. And now for, I guess, just 0, right, for all the rows in 0. So for each time this happens, so let's see, for, yeah, I guess we can just do for let I equals 0, I less, then matrix dot length I plus plus the matrix at that row equals matrix at that row plus or equals 1. All right, for let I equals 0, I less than matrix dot length, the matrix at that row, which is just not change, equals 1. And the same thing for the column. So the column is always like confusing for me because what is it that we want to do? Like for that second one, column, we want to go row 0, column 0, row 0, column, column 1. This is the thing that's increasing, right? Column 2, this is going to stay the same. And let's say it was like row 3, column 1. So I think, yeah, here we can actually do for let I equals 0, I less than matrix dot length I plus plus. We can say matrix at row column equals matrix at row column plus 1. And I realized that I also got something messed up here because this is going to be the other way where the row will always stay the same but the column will increase. So row, and this will be I. Right, row will stay the same, column will increase. That's what the I is for. So row I equals matrix row I plus 1, and then I less than 0. Here we have I increasing and column the same. I column. All right. Can we do the same for both of these? I could, right? Like I don't need to have these in separate for loops here. I should be able to just do this. And then finally at the end, we can do for let row equals 0, row less than matrix dot length, row plus plus, for let column equals 0, column less than matrix at row dot length, column plus plus. Here we just say if matrix at row column is odd, then we just say, let's see, odd values equals 0. We'll just increase odd values plus 1 and return odd values. Let's see what this does. Crazy, like I understand why this is probably not liked very much. Okay, so 2, 6, so we got something wrong here. Increments all the cells on row Ri, increments all the cells on column Ci. Okay. Matrix row column, matrix row dot length, 0, 0, 0, matrix I. Let's see, so we're creating it with array M, I 0, I less than M, matrix at I equals new array of size n dot fill 0. We get the row column from the index and indices. For let I equals 0, I less than matrix dot length. Oh, but wait, because it's gonna be different, right? Because the row, oh, that's weird. I would have almost expected for it to go out of bounds, but yeah, we'll need two separate ones here. The row can be matrix dot length, but this one should be written a little bit differently, right? Because this is gonna go at 0, but this should really go to, if I go to 0 dot length, that's still gonna be the same though, right? Oh, matrix dot length is the column. This should be matrix row dot length. This should be matrix dot length. So does this change anything? 6 and 6, okay. So let's run the next test case here. Went too fast. 6 and 0, 6 and 0. Did we get the answer? 85.98. So kind of a weird question. Like we generate our array. So we generate the array up here, and then we just go to the index array they provided for us, and we do these operations, keeping in mind the different lengths of the rows or columns that we're on. And then we have to go through it again and parse all the values to see if they're odd, and we just add it to this odd value. So it's more just like a going through the motions questions, I think. I don't think there's too much value in this question, so I'll just go ahead and continue. Probably going to keep the stream going for like another 5 minutes, and I'll wrap it up here. I'll be just at the top of the hour. But let's see, increasing order search tree. So we have, given the root of a binary search tree, rearrange the tree in order. So the leftmost node in the tree is now the root of the tree, and every node has no left child and only one right child. Oh, this is going to be fun. But you know what? I think, can I, Like what if we, let me see, 5, 3, 6, 2, 4. I really want to draw this one out. So I'm going to move the LeetCode window out of the way and go to Excalidraw, because this one is definitely worth it to draw out. I think we'll only be able to like really do it right if we draw it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, and we have these 2 nodes on either side. Then we have 2 more on these sides, 1 more over here, 2 more down here, and then 1 over here. Let's draw our arrows. So doing an exercise like this is, I think, really what helps cement all these questions in your head. Like unless you go through the motions, it's going to be really hard to like learn. So highly recommended. And this is coming from someone that generally did not like to draw, but man, it saves so much time and you really do learn a lot. So highly recommended to go through that process. All right, so over here we'll have a 6, we'll have an 8, we'll have a 6, 8, we'll have a 7, and then we'll have a 9. So what I'm thinking, like, what if I start going through each one of these? Like I start at 5, then I go to 3, then I go to 2, then I go to 1. So like this is my, I guess, my root here. So what if I were to just return, like what if I create a new root down here and I return that? So let's say, let's get this thing again, right? So now my root, like new root, let me make this large, and I'll make it a different color here. So let's say new root equals 1, and let's just say null, because really this is essentially a linked list. That's what we want to make it, right? So if I return new root now, let's think about this. Really what I want to do is append, well, it doesn't want me to return a new list, does it? I don't think it wants me to do that. Rearrange the tree in order so that the leftmost node in the tree is now the root tree. Can we just do it in place? Like, so if this is a leaf node, let's just return, what if we just return 1? Like let's say here we'll just return 1. And now when we have the 1, we're up here. So can we just now add like 1.right is equal to the current root. Okay. But now if I return this, yeah, and then it would be nice if I can just like, well, wait, if I'm going right, I don't need to process the ones on the right, I don't think. I just need to make it so that the Yeah, there's like a couple different ways to do this one, I think, because as I'm going through it, I realized that maybe let's put it up on the screen again, like what it is that we're trying to do. The leftmost node is now the root of the tree. You know what though, like maybe I'm thinking to start this way first, but what if I start from the right and I start going down each one of these? If I start at 9 and return that, I don't need to do anything with this. Then I go to my left, I return the left, and I make the note. Yeah, right? What if we do, so go all the way right, and then return from null, go left, return left, and then left dot right equals the current root we're on. And then we can just return root. So that gives us that. And then if I start going left, I don't want to just return left. Oh, I should go all the way left, right? I'll go left, and then I'll go right, return from null, go left, return left. See, then it gets a little bit tricky. Yeah, I think because like I just hit the top of the hour and I've been doing a lot of LeetCode today, and I'm pretty happy with like how this stream turned out for what it is. So I'm gonna add this to the list of things to revisit. And again, it might not be at the end of the week during like the weekly roundup, so you might not have to wait all the whole time. So thank you all so much for watching. If you like what you see, and if you feel like you're making progress on your LeetCode journey, then please join in. Let me know how things are going for you. Let me know what you're struggling on, what you're doing well on, how many questions you've solved. I'd love to hear that. I'd love to talk about it on the stream so I can let all the other viewers know about other viewers' progress. So thanks again for tuning in. I had a great time solving some questions today, and let's see how many we're at now. We are currently at 67, so only 33 questions away from hitting that 100 question milestone. So I'm excited to be able to get there with you all. Have a nice rest of your day. Happy coding, and we'll see each other next time.